from here on out. Good catch. All right, so we're looking at solving systems with three variables. So to check your solution, you would plug it in. So if you plug it into this first one, you would see that it does work. 2 plus 1 plus -4. Like that would really be 3 plus -4 is -1. That is true. But the second one's an issue because you'd have 2 minus 1 minus -4. That would really be like +4. And you'll see if you work that out, that would be -1, or sorry, that would be +1 plus 4, that would be 5. But either way, it's not -3. So since it doesn't work for that one, you don't even have to check the third one. I think it might work for the third one though, wouldn't it? 4 minus 1, that would be 3 minus 4. Yeah, it would work for the third one, but you don't even have to check it because it doesn't work for the second one. It has to work for all three. But so that's how you can check your answers as we're going through them today, because your answers are always going to be in this form x comma y comma z. So let's look, we call these triangular equations for these ones because they kind of almost make a triangle with how they're shaped. I don't know. But these are kind of simple examples, like where we already have one of our variables. So like if you look at this question, we already know the answer to z is 3. So like even if we wanted to put like our spot, like I know my z is 3, we got to find our x and y. So if you have an equation that's kind of set up like this, you can kind of plug, like if you plug it into this middle equation, you can solve for your y. Like this would be y minus 3 times 3. So that would really be y minus 9. Or if you add that 9 over, you would get +2. So that's our y. And then now that we know our y and z, we can plug that into this top equation, and we could isolate the x. So we would have x plus 4 times y, or y was 2, so that would be x plus 8 plus z, or z was 3, equals 12. So that would be x plus 11. And then if you subtract, you would get x equals 1. So our answer would be 1, 2, 3. And you could plug it into those and see it works. I mean, these ones are kind of strange because not every equation has all three variables. So this is kind of like a special case. But if you do see a question like this, you should be happy because we're going to see it's a lot less work than if you have equations with all three variables. So this is a special case called a triangular equation. But how about you try this bottom equation? Let me just erase that. But see if you can kind of work. You're going to work kind of bottom up. So, but see if you can solve for your y and then solve for your x. So they're giving us the z right now. So take a second, see if you can solve this.
You're going too fast.
All right, I'm sorry. But see, so if you want to try this one, see if you can plug it in to the second equation to solve for your y. And then once you have your z and y, plug it into the top equation to get your x. This one. So since you already have your z, you're going to plug that into this equation that only has two variables, because if you plug in for the z, well, then you can get the y by itself. So this would be y plus 1 equals 4. If you solve that, you would just get y is 3. So now that you know two of your variables, you could plug it into this top equation. So like we don't know the x, but we know everything else. So it would be -3 because that's your y. And then 2 times z would be 2 because 2 times 1. But if we clean this up, -3 plus 2 would be -1. If you add the 1 over, you would have 6. Divide, you would get 3. So your final answer would be 3, 3, 1. And I saw a few more people sent me that, so good. So this is honestly, like in terms of like a three system of equations, this is as easy as it can get. Like, I mean, this is like the dream situation where they give you one of your variables. We're going to see in the next problems we're going to start looking at, and we're not going to, I'm going to say right now, we're not going to finish these notes today. We'll probably finish them up tomorrow. So we'll see how far we get. But we're going to see we basically have to use our elimination process a couple times to kind of create what we just had here. So we're going to see these problems have a lot to them, but once you get the process down, it's not hard. As long as you can do elimination and you can plug in and solve for variables. The process itself isn't difficult. There's just like a lot of steps in getting used to like what you need to do next to get this, so you kind of meet these certain requirements. So there's these 6 steps we're basically going to be following in these problems, but we're going to see a lot of times when you're doing problems, nice things will happen, and sometimes you'll be able to skip steps. So we'll kind of see that as we're going through examples today. But your first step is you're going to choose any 2 equations. And you're going to eliminate one of your variables using elimination. I mean, you could use substitution, but honestly, like all the problems we're looking at today are going to be kind of set up for elimination. I would highly, highly, highly encourage you to use elimination method for these types of questions. But if you really don't like it, you can try, and if you want to do substitution and kind of go through it and see if you can do it, that is up to you. So we're going to choose 2 equations and eliminate one variable using elimination. Then for step 2, we're going to choose 2 other equations and eliminate the same variable using elimination. So what this is going to let us do, basically, if you eliminate the same variable, like let's say you eliminated the z's from both equations, you're going to get 2 new equations that just have 2 variables. So with these 2 new equations, you're going to do elimination of one of the variables. So like after step 3, basically what you're going to have accomplished, and we'll see how this looks like in a problem, but basically what you would have accomplished is you're going to have x equals 3, or you're going to have y equals 2, or you're going to have z equals 5. Basically, you're going to have solved for one of your variables. Once you've got one of your variables, you're going to substitute or plug the one variable you got back into one of those 2 new equations you made. This will let you solve for your second variable. So like now you would have z equals 2 and y equals 3, for example. And you would be able to substitute this back in to any one of the original equations you had. And this would let you solve for your final answer. Step 6, and this is a step we're all guilty of skipping at some point in your life, but you can always check your answers by plugging them in to all 3 original. I would encourage you to do this maybe on the test, but a lot of times when you're just doing like practice or homework questions, sometimes you just take that risk. It's up to you. It depends on your personality, how risk averse you are, or how lazy you are. But I know I don't always check my answers, and maybe I shouldn't say that, but I don't know. So this kind of diagram is, I don't know if it's helpful, but basically I didn't make this note sheet, but I found this, but they just kind of like, if it helps you to think about your steps, you're going to eliminate with 2 equations, you're going to eliminate with 2 more. But basically, this is just your steps. I don't know. They made steps to illustrate the steps. But you're going to substitute. I don't know. Maybe this is just excessive. But you're going to substitute into step 3. Crap, did I? Oh, wait. Dang it. I even messed up. I'm sorry. You're going to eliminate, eliminate, eliminate. You're going to substitute into step 3. But I don't know if this is even worth writing, but I'll just do it since I'm committed. And then you're going to substitute to get your final answer and then check. It's just kind of illustrating those 6 steps. All right, so let's get into a problem. Let's see how this actually looks in action. And we'll see. It's going to be tough for me to squeeze in on this iPad. We'll see how this goes. So we've got 3 equations. Just so you know, I usually just number them. I call this like equation 1, this equation 3, this equation 3. So if I say equation 1 and 2, I'm talking about the top two. If I say equations 1 and 3, I'm talking about the top and the bottom one, just so we're clear. So the first thing we're going to do is we're going to pick any two equations, and we want to do elimination. So it doesn't matter which ones you do. If it looks easier, like, I don't know, maybe like the first and second equation, it looks like it's really easy right now to eliminate the z's. So maybe I'll pick those two. But it doesn't matter which two you pick. You could always do the same order. But I'm going to do equations 1 and 2 to start. So I'm just going to write those equations down. So I have 3x minus y plus z. And then I have x plus 2y minus z equals 1. And you want to decide what variable to get rid of. So I'm going to just do the z's because it's already kind of set up nicely for that. Like, I can eliminate the z's right now. So I would have 3x minus y equal, or wait, what am I doing? Sorry. We would add our x's, so I would have 4x, negative y plus 2y would be 1y, and then negative 15 plus 1 would be negative 14. So that's one of my new equations for right now. Step 2, we're going to pick two different equations. So I can't do 1 and 2. Like, I could do 1 and 3, or I could do 2 and 3. It doesn't matter either. So if, for example, it looks like it's easy, because since we got rid of the z's, I got to get rid of the z's for this one. So I got to pick two different original equations. So I just can't do 1 and 2. I could do 1 and 3, or I could do 2 and 3. I'm just going to do, like I said, it doesn't matter. It doesn't really look any easier either way. I'm just going to do equations 1 and 3. So I'm just going to copy the first equation. And I'm going to copy the third equation. Here's the deal. Since I got rid of z's in the first equation, or like in the first step, I got to get rid of the z's in the second step. So I need to switch, like I need to make my z's the opposite. So since I have negative 2z on the bottom, I need to make the top z a positive 2. So I got to multiply the top equation by 2. So I'm just going to write that below. So I would have 6x minus 2y plus 2z equals negative 30. And now I'm kind of like not looking at this one anymore. These are my two equations now, like here, this purple one and the red one. So now we could do our elimination. I would get 8x plus 1y. My z's would cancel, and I would get negative 30. So this is my second new equation. So steps 1 and 2, basically, we're trying to come up with two pairs of equations, and we're trying to get rid of the same variable. And we didn't have to do z's. We could have gotten rid of like the x's for both, or you could have got rid of the y's for both. But your goal is to create two new equations where you just have two variables. So step 3, we're going to put these two new equations we got here together, and we're going to do elimination. So I have 4x plus y equals negative 14, and I have 8x plus 1y equals negative 30. So it's up to you. You could either cancel out the y's or you could cancel out the x's. I'm feeling like I want to get rid of the y's. I don't know why. It's not like the x's are any harder. So I'm going to multiply the top equation by negative 1. So I'm just going to write that down below. So that would be basically just switch all my signs. So now I can do elimination, like my y's would cancel. I would get 4x equals negative 16. So x would be negative 4. So now that I know my x, I could plug it into either one of these equations I had down here, and I could solve for my y. So it doesn't matter which one, if one looks easier for some reason, but I'm just going to, for sake of space, I'm going to plug it into this one. So 8 times negative 4 plus y equals negative 30. that would be negative 32. So I would get y is positive 2. So now that I know 2 of my variables, I can plug it into any one of my original equations and solve for x. Honestly, I like this one because I don't have a coefficient with my x, so I won't have to do a division step. So I would have x plus 2 times y. That would be 4 minus my z was negative 4, so minus negative 4 would really turn into a plus 4. So if I work this out, this would be x plus 8 or x equals negative 7. So my answer, oops. Wait, what did I plugged those in for the wrong things. Sorry. So I already had my x, so sorry. I guess I didn't really pay attention to what variable I'm missing. So I'm missing my z. So sorry about that. So I would plug in negative 4 for x, plus 4 was my 2y, and then I don't know my z. Okay, so this would just cancel. So I would have negative z equals 1, or really z equals negative 1. So sorry about that goof. But my answer would be negative 4 to negative 1. And we are out of time, but that would be my final answer. That's how these problems go. I know it's a lot of work, but once you get this down, like it feels like an accomplishment when you get through it. So tomorrow we will look at a bunch of examples together. I think on Thursday we'll have our assignment over this. So I kind of want to spread it out. Friday maybe we'll review, or Monday we'll review, but I'm planning on moving the chapter 2 test till next Tuesday because I don't want to have a Monday test again. So I'm going to push it back a little bit in terms of our schedule, but we've got a minute left. I don't know if there's any questions that I could answer in time either. But just so you know, I did post the key to these notes. So if you want to look at the example we did or any of the future ones, but we will go through examples 4, 5, and 6 tomorrow. And then we'll start working on the assignment tomorrow and probably definitely Thursday as well. So I'm going to change the schedule I posted and I'll update like kind of my plan. So no homework tonight.